In this video, I would like to briefly go through some exercises in 8.4 and 8.5. As you found that these sessions are very hard because it is related to writing reasons clearly. So in this video, I would like to just give you some brief ideas so that when you look at the solutions, you can follow it easily. Number 1 to 6 are questions for you to familiarize with the properties of rhombuses, rectangles, and squares. Also, how do we present? Okay, for number 1, we can write A equals to 90 degree directly. A equals to 90 degree is property of rhombus, and then 40 plus B is 90 degree exterior angle of triangle. B equals to C, property of rhombus, and then D equals to 40 degree, also property of rhombus. Why? Because for property of rhombus, you can say these four angles are equal. Of course, if you don't want to say property of rhombus, you can say D equals to 40 degree, and then alternate angles AB parallel to DC, it is also okay. For number 2, you can say R equals to 8, property of rhombus, S equals to 6, property of rhombus, P equals to Q equals to 10. These three are equal because it is also property of rhombus. For property of rhombus, you have all the four lengths here the same. Okay, look at number 3. You can claim A equals to 7 opposite sides, so it is property of rectangle. B equals to 13, property of rectangle. C 90 degree, D 90 degree, property of rectangle. Okay, number 4, you can say P equals to 4, property of rectangle. Next, in order to find the angles, it may not be so straightforward because there is no property directly related to these angles, and you cannot claim R equals to S directly as well. However, for rectangle, you can say all these four lengths are equal. The diagonals are bisected into 4 equal pieces. It means that you can claim EB equals to EC, property of rectangle, and then these two are the same. It is base angles isosceles triangle. So you can have 2S, add them together would be 60 degree exterior angle of triangle. So you can find S equals to 30 degree. So after you find S equals to 30 degree, it means that this one is also 30 degree, ECB is also 30 degree. Because you can say property of rectangle, you have BCD equals to 90 degree, so you can find out Q easily by 90 degree minus 30 degree. So finally, you can also claim this one is 90 degree, so you have R plus 90 plus this Q would be 180 degree angle sum of triangle. So this is the approach. However, you can find that the solution is slightly different, so you can actually have more than one ways to find all these angles. However, you just need to mention EB equals to EC or EC equals to ED for base angles isosceles triangles. Look at number 5. So this is quite straightforward. This is a square, so you can say A equals to 12, property of square. B equals to 90 degree, property of square. C equals to 45 degree, property of square. That's finished. Number 6 is also very straightforward. You can say R equals to 90 degree, property of square, and then Q plus 1 equals to 5, P equals to 5, also property of square. And then you can calculate all the things. For number 7 and 8, actually things are very similar. However, just to note that there are no reasons like property of kite, property of trapezium, there is no such thing. So you have to write like this. You just need to mention because ABCD is a kite, it is actually to replace that property of a kite. And then x equals to 3, y equals to 5, and then that is already done. 可能你覺得有啲屈機，不過係啊，我哋冇 property of kite 嘅，咁你就寫因為佢係 kite，所以 x 等於3 y 等於5啦。For number 8, we also use similar trick. We write because PQRS is a kite, therefore M equals to 110 degree. Why? Because these two angles are the opposite angles, and then you can claim that because these two are congruent triangle, so you can say M equals to 110 degree. It is a property of kite, but there is no such reason. So you write because PQRS is a kite, M equals to 110 degree. And then in order to find N, you can write angle sum of polygon. All the four angles added together would be 4 minus 2 times 180 degree. For number 9, it is a bit special because it is not given for you that AECD is a rectangle. However, you should know that it is. So how should you present your things? You can say angle EAD can be found by 360 degree minus 90 minus 90 minus 90 angle sum of polygon. So after you calculate this is 90 degree, then you can say because all the four angles are 90 degree, then you can claim that AECD is a rectangle. However, you never see this before. Never mind, there is no reason for that. You just need to say that because it is for the definition of rectangle, all the four angles are 90 degree, then it is a rectangle. So after that, you can say A equals to 10, property of rectangle, and then boy E equals to A, given. So you can find out B easily after you find EC equals to 8, property of rectangle as well. For number 10, you can find out A easily by interior angles. A plus 65 degrees is 180 degrees. So in order to do it in a long question, so you learn that the only way is to construct a line like this, DE parallel to AB, and then you can find out this is ABED is a parallelogram. So for a parallelogram, you can copy this length to be 11 cm, and then C can be found here by corresponding angles. So this is the only way in long question. However, I also want you to know that if it appears in the MC question, I want you to know for isosceles trapezium, actually it is always true. C equals to 65 degree. It is always true. So you can also bear in mind that this is a property of isosceles trapezium. It is only that you is not allowed to use directly in long question. For number 11, I think the answer is very obvious. However, how to present? First, because it is a rhombus, in order to claim that boy E is half of 24, you have to write the property of rhombus, BE equals to ED, property of rhombus, and then AE equals to EC, also property of rhombus. So in order to find out the length, let's say AB, then first of all, of course, you have to use Pythagoras Theorem. Before that, you have to mention that AEB is a right angle. Angle AEB is a right angle because it is also property of rhombus. So after you write all these reasons, then you can use Pythagoras Theorem to find out AB. And then you can write the perimeter of ABCD equals to AB times 4. However, it also involves property of rhombus because all the four lengths are equal. For number 12, it is asking you to find out angle DCE. So you can see there are two rhombus here. So how to make use of the property of rhombus? First, I think you can find out this angle boy C dot. This is not property of rhombus, but you can find by interior angles. A boy parallel to DC. So you can find out BCD equals to 80 degree. Then you can make use of property of rhombus. It is this line AC bisects the angle into two halves, so you can write 40 by property of rhombus. And then you can also find that angle ACE by looking at another rhombus, 80 degree plus angle ACD, interior angles AC parallel to FE. So after you have found these two angles, you have the big minus small to find out angle dot CE. That's finished. For number 13, you have the perimeter of this equals to 50 cm because it is a rhombus, so you can find out FD by 50 over 4, property of rhombus. And then after you know FD equals to AF, this is property of rectangle. And then you can claim angle AED is a 90 degree, property of rectangle as well. So you can find out ED by Pythagoras Theorem, 24 square plus AD square. No, AD square minus 24 square is ED square. Then you can find out this. So finally, AB is also equals to ED because property of rectangle. Number 14, you're going to find out angle ACE. So my suggested way is to find out these two angles first. How? Because BG equals to GC, this is property of rectangle, and then you can use vertically opposite angles to write 130 degree here. Then using base angles isosceles triangle, you can find out 25 degree using angle sum of triangle as well. So finally, you can copy this angle to angle BOICE because it is alternate angles which two parallels BOI dot parallel to EC. So you can find out 25 plus 25, which is angle ACE. Number 15, the keyword is identical. So when you see identical squares, then you can claim that BOI dot equals to dot F. You can say given or just leave it. And so you can find out BOI dot equals to 14, dot F also equals to 14. So in order to find out the area, of course, you need the length of the square. So how to do that? Because AB equals to AD, you have to claim it first using property of square. So after that, you can let both of them be A, for example. So this question involves some algebraic skills. So let me show you how to do that. In order to use Pythagoras Theorem, of course, you need to mention angle BAD is 90 degrees first. Don't miss it. It is very easy to miss. Alright, so after you calculate A squared plus A squared is 14 squared, or I think most of you would try to solve for A. In order to solve for A, of course, that is okay. Let's try to do it, where you can say A equals to square root of 98. However, if you are smart enough, then you can just stop at here. Why? Because you can find 2a squared equals to 196. But look at the questions clearly. It's not asking you for A, it's asks you for total area of the two square. So what is the total area of the two square? This is exactly 2a squared. So you can claim the answer 196 cm squared directly after you find 2a squared equals to 196. So I hope this is a very tricky question for you to learn. Number 16, you can claim angle A dot BOI equals to 45 degree property of square, and then because dot BOI equals to dot E, so you can find out these two angles being the same base angles, isosceles triangles, and then you can use angle sum of triangle to find out these two angles as well. These two angles can be found, and then you can use the blue angle A BOI dot, which is 45 degree. You have to big minus small to get the answer 7.5 degree for ABE. For number 17, it is a kite. So remember, there is no property of kite, but you can say because PQRS is a kite, so this one is 110 degree. So in order to find out angle PSR, you can use angle sum of polygon. Four angles added up together would be 4 minus 2 times 300 times 180 degree. Then you can get the answer. Look at number 18, there are two key points. The first point is that you have to mention AC perpendicular to BD because ABCD is a kite. This is always true, and you can claim that without writing property of kite because there is no such a reason. The second tricky point is related to ratio of area. So in chapter 7, I taught you one trick is that if they share the same height, you can see angle A, triangle ABOE and triangle AED share the same height, and then the base is 1 to 3 in ratio. So you can claim that the area of AED is 4 times 3, which is 12. And then after you know that ABD is congruent to BCD, you can also say that the lower part of the kite is 16 as well. So you can find out the area of it easily. So the tricky point is that you can find area of triangle AED by 3 times 4. This is a tricky point, and you have to learn this because they share the same height. Okay, number 19, let's go through it briefly. You can use the property of rhombus to say that the two angles here are both 54 degree. After that, you can use interior angles to find out the red angle here, which is 72 degree. So after you find this 72 degree, you can copy it here by alternate angles AD parallel to BC. Using the fact that DC equals to EB, property of rhombus, then you can use base angles isosceles triangle 72, 72, and you can find ABE easily by angle sum of triangle. Number 20, it involves a square and a right angle trapezium. So first of all, you can claim all these four angles are right angles using property of squares. And then you can say all the four lengths are 5 cm. I think this one is 5 and boy dot is 5 would be quite useful for you. So in order to show that boy dot C is a right angle, you can say because A boy dot is a right angle, so boy dot C is also a right angle because of alternate angles boy A parallel to CE. So after that, you can use Pythagoras Theorem to find out BC, which is 12 cm. So for finding out the perimeter of ABCE, you just need to add 5, 5, 12, 17, then you get the answer. Look at number 21. So your goal is to find out angle AGD. So obviously it makes use of the fact that AD equals to DG, base angles are isosceles triangle, then you can find out AGD. So it means that the goal is to find out angle A dot G. So how to do so? You try your best to find out the two blue angles, and then using adjacent angles on straight line, you can get A dot G. So how to find out the blue angles? Let's look at the right one. It is easy because it is 38 degree. You can say property of rhombus, or you can say alternate angles GD parallel to FE. Okay, so looking at the left side, there are many ways to find out the blue angles. One of the ways I can introduce to you is that you can claim this one is 46 degree as well because it's property of rhombus, and then find the total angle A dot C, which is interior angles A dot parallel to boy C, and then you can claim A dot boy is half of that. This is a property of rhombus. Of course, there are many different ways. For example, you can claim AH dot is 90 degree. It may also help you. So there are many different ways. You can try your own way. Okay, number 22, it is a rhombus. It means that it is a parallelogram as well. So you can find out angle A boy C is 72 degree. Alternate angles A boy parallel to DC. And then because A boy equals to AF, so you can also say AFB is 72 degree. Base angle are isosceles triangles. And then angle sum of triangle, you can find out this angle 36 degree. So because it is a rhombus, you can say AC would cut the angle dot AB into two equal halves. So dot AC is 36 degree as well. Because by the given fact that AE is an angle bisector of angle FAD, so you can also claim that these two are 18 degree afterwards. So in order to find out angle AEF, everything is clear now. So you can just use angle sum of triangle, or you can use exterior angle of triangle to get it. For number 23, this is a question without any diagram, so I suppose you can draw the diagram yourself as a draft, and you can find out the lengths of AC and BD respectively. So for this question, actually there are two tricks that you learned before I want to review with you. The first trick is that when you see ratio, you can use K method. What is meant by K method? Because for 2 and 5, they are not actual values, so you can use 2K, 5K as the lengths for AC and boy dot respectively, so you can find out K afterwards. And the second trick is that area of rhombus is something that you learned in grade 7, and hope that you still remember that. There is a formula learned in grade 7, chapter 10, that the area of a rhombus, or area of a kite as well, the area is given by 1/2 times AB. AB are the two lengths of the diagonals. So please remember that, and this will be very useful in this question. So using K method, you can let AC be 2K cm, BD be 5K cm, and then you can use one formula to get K equals to 4. Remember to find out the lengths of the diagonals by putting K inside the formula. And then you can have AC equals to 2 times 4, BD equals to 5 times 4, then you can get the lengths for part A. Next, you need to find out B, the perimeter of ABCD. It means that you have to find out the length of one side only and then multiply by 4. In order to achieve that, you can claim that, let's say M is the midpoint, and then AM equals to MC, property of rhombus, dot M equals to MB, property of rhombus, and then you can find the length of AM as well, and also DM, and you can claim that angle AMD is a right angle, property of rhombus, Pythagoras Theorem to find out AD. So in order to present it nicely, perhaps you can say let M be the intersection of AD and BD, AC and BD. Then I think things will be easier to present. Okay, number 24 is quite easy because it is a rectangle, so you can claim TS equals to TR, property of rectangle. Then you can find out X easily using one equation. So next, you want to find the area of PQRS, so you can say PT also equals to the same length because for rectangle, all these four lengths are equal. So after you find out PR, you want to use Pythagoras Theorem to find PQ, so you have to claim angle PQR is right angle, property of rectangle. So you can find out PQ, then you can find the area of PQRS easily. Look at number 25, your goal is to find out angle C boy F. So I suppose you would need to find angle boy CF and also angle boy FC, then you can use angle sum of triangle. So how to find angles boy CF? This one, I think you can use alternate angles of parallel lines to show this one is 25 degree, or you can say property of rhombus as well. And then angle boy CE is a right angle, then it is 65 degree by right angle minus 25 degree, which is quite easy to get. Next, in order to find angle boy FC, you can claim angle FEC equals to 25 degree first, property of rhombus, and then you can find angle EFC using interior angles ED parallel to FC. So after that, using angles at the point to get angle boy FC. So after you have angle boy FC, angle boy CF, then of course you can find the remaining angle easily. Number 26, I think the answer is not hard to get, but how to present or how to use reasons to present it is quite hard. Also, how to find the perimeter of AC dot E, which is a parallelogram. Also, first you have the information that the area of the square is 64 cm square, so you can first claim that AE equals to AB equals to BC equals to EC, property of square. After you know property of squares, then you can claim that the area of the square is 64 cm square, then AB would equals to 8. All of these lengths would equals to 8. Alright, so next you want to find AC. So this is a diagonal of the square. You can write angle A by C is 90 degree. So using this fact, using Pythagoras Theorem, you can find out AC easily. And after you find AC, E dot equals to AC, opposite sides of parallelogram. So for this one, please remember we do not write property of parallelogram, we write opposite sides of parallelogram. This is special for parallelogram. So after that, you can also claim C dot equals to 8 because opposite sides of parallelogram. Then you can add up all of them using 3 significant figures as your final answer. Look at part B, you want to find perimeter of triangle EFD. So how to find this? I think the length for FD would be quite hard. For EF, you can claim that because this is diagonals of parallelogram, so EF equals to FC. You can find EF equals to 4, which is half of the length of the square. But for FD, you have to find A dot first. How to find A dot? A dot can be considered in this right angle triangle. So you have A boy already. You also have boy dot already. So you can use Pythagoras Theorem to find out A dot and then take half of it to be FD. So add up all the three lengths, you get perimeter of triangle EFD. Look at number 27, I think the trick is you have to consider AEFD is a square. So it is very obvious that AE equals to EF equals to FD equals to 6 cm. So also you can claim AEF, EFD, FDA, DAE, all of them are 90 degree. It means you can find angle AEB as well, which is 90 degree by adjacent angles on straight lines. And then angle sum of triangle, you can find out this one is 45 degree. So previously, I've already showed you how to prove that the two base angles are equal for an isosceles trapezium. So if you are not allowed to use these facts, then this question becomes very complicated. Never mind, so I just treat it like an MC question to discuss with you. So this one is 45 degree. So you can also find out angle f dot c is 45 degree as well. So this one is 90 degree. So how do you find the length using the two 45 degrees? I want to tell you the reason because most of you may have forgotten about it. So in order to claim that the two lengths are equal because the two base angles are equal, you can say boy E equals to EA, and the reason would be size opposite equal. Equal have to be written as a full names, equal angles. Why? You have to claim the reason because angle A boy E equals to angle boy AE. You can write equals to 45 as well. So after all these analysis, you can find boy E equals to 6, EF equals to 6, FC equals to X, C equals to 6, and you can find BC easily. And finding out the area of the trapezium, it is just upper base plus lower base times height over 2, which is quite simple for you. So you can do this 27 easily. Okay, now look at number 28. It is super challenging. Usually it would not appear in long question because it would be so complicated to present it. So I just try to treat it like an MC question to discuss with you, but it is still very challenging. This question is related to similar triangles and also area ratio. So you can think like what I'm going to demonstrate to you. First, you can show that triangle AMD and triangle BME are congruent triangles because of these three conditions. So if the area of AMD is A, then area of EMB is also A. Next, we can show that triangle EMB is similar to triangle EDC because MB is parallel to DC. You have at least two pairs of corresponding angles equal. Because M is the midpoint of AB, and AB equals to DC, property of rhombus, so you can say MB to DC is 1 to 2. Since the length ratio is 1 to 2, the area ratio of EMB and EDC would be 1 to 4. So if I only consider MBCD, then the area would be 3A. Now I can find all the area of different pieces, and you can know that area of AFEM is the same as area of ABCD, so you can also write down area of AFEM is 4A. Now our goal is to find FA to AD, so let me try to let them to be x and y respectively. In order to find the ratio of x to y, I try to consider the area of FE dot, a triangle. So base times height over 2, let h be the height of this triangle. And also consider the rhombus here. We have y times h because h is also the height of this rhombus. After considering these two areas, then we can combine them as one equation like that. After some simplification, you will get the result x to y equals to 3 to 2. Oh my god, it is really challenging. Okay, but I hope you enjoy it. Now look at number 29. Although it is a star question, but I don't think it is as challenging as the previous one. Well, in order to find out x, you can consider some properties of a kite. For example, AE equals to EC. E is the midpoint of AC. And then you can also say AC is perpendicular to BD. So by using these facts, then you can claim AE is x easily. Then using Pythagoras Theorem, you have x squared plus 21 squared equals to x plus 9 squared. After expanding these terms, then you can get x easily. X is 20. And then for part B, because AE to BE is 1 to 2, so after you find AE is 20, then you know BE is 40, this one is 21, so we actually get all the lengths already, so finding out the area of the rectangle is just 61 multiplied by 40. For part C is also quite easy because for finding out the perimeter, you just need some Pythagoras theorem to find out AD, AB, and then the lower part is just the same as the upper part, so you can just multiply by 2 to get the final answer. The only challenging point is that you have to leave the answer in short form, so you should keep the answer like this with a bracket CM to be the answer. So the last question 30 is quite challenging. Your goal is to find the area of a regular hexagon of side length 1 cm. In fact, if the hints are not given to you, you can dissect it into different ways to find the area of that. Also, I will try to show the idea of how to find the area, but the steps will be very tedious. So first of all, you should know the facts that for a regular hexagon, each interior angles would be 120 degree, and that all the 6 lengths are 1 cm. By joining BE, you can now have two trapeziums. Actually, the two trapeziums are the same. So this 120 degree are cut into two halves, so you have 60 degree here. And try to draw AM here. I hope you still remember sine, cosine, tangent. Our goal is to find BM and also AM. I hope you still remember this. In order to find out BM, we have the hypotenuse, we have the angle here in a right angle triangle, so you can use sine, cosine to get these two lengths. Now we have the lower base, we have the upper base, we have the height, so we can find out area of the trapezium and then multiply by 2 to get regular hexagon's area. Now move on to the second case. If we cut into this way, then we have two isosceles triangles like ABC and DEF. So using sine and cosine, you can find BM and CM respectively. So you can find the area of these easily by base times height over 2. And also AF, you know it is 1 cm, so you can find the rectangle's area as well. So you add up all together, then you get the area of the hexagon. Finally, let's move on to the last case. This case cuts it into 3 identical rhombuses. It is not easy to show that they are rhombus, but you can feel that they are actually 3 rhombuses. So after you find all the interior angles, again you can use sine, cosine, tangent to find out the height here. Because they are rhombus, so GE is 1, and then, actually you can use AF as the base as well. And then finding out the height, which is FM here. FM can also be found using sine 60 degree equals to FM over 1. FM is root 3 over 2. So you can have 1 times root 3 over 2 as the area of the rhombus and then multiply by 3 to get the answer. So that is the end of this exercise, and I wish you have enjoyed this video. Goodbye. I didn't enjoy. I died.